Hey guys, welcome back to yet another A-level maths video. This time, again, we're going through all the problem solving stuff, by the way. This time, it's the very attractive topic of modelling. Now, modelling in general kind of sucks for students, and I completely understand why, because you have to apply it to situations you may not really think about before. So in this case, it's talking about a Ferris wheel. Sure, I guess. But again, we're going to go through modelling with trigonometry. Now, the good news about this is most of the parts stay the same. So, for example, things like the maximum height and the first part is normally the same, as well as part B. Part B, when I say normally the same, C and A are basically identical. B, very similar. D, it's a toss-up, but essentially they say it's always adapting the model. That's what they kind of ask you. A is always finding the whole r cos theta plus alpha thing, super standard. But yeah, I would say B, C, and D are not always answered very well, so hopefully when I go through it, it'll kind of give you an idea on how to think about these types of things. So, let's start off with 3 part A. Now, doing something like this, there's a few things you can do. You can either just use essentially the equations, but the way that I prefer to do it, in an exam anyway, is to actually write out using the addition rule what the answer is. So if we do r cos theta plus alpha, you get given the addition rule in the exam. So I'm going to show you how to do it this way, just so you're not relying on memory, because relying on memory, especially when you're under pressure, and especially when you've have like 4 different exams in a week, it's not very reliable. So again, the addition rule just says that you have cos theta cos alpha, so cos of both of the things, minus r sine theta sine alpha. And the way that this method works is you essentially make these two equal to each other. The reason why we can do that is simply because we're trying to write this in the form of this, which means they both should be equal to each other, right? The form on the right should be equal to the form on the left. And then all we do is we compare coefficients. So if we look at everything in front of cos theta here is the same as everything in front of cos theta here. So if I compare cos theta, we get r cos alpha equals 10. Because again, everything in front of cos theta here, all the coefficients of cos theta, which is cos alpha and r, is the same as the coefficients of cos theta on this side, which is just 10. Do the same thing for sine theta. We get negative r sine alpha equals negative 3. That's it. Cancel out the negatives. And then from here, you can work out alpha and r. Here's how you work out alpha. You divide these two equations. So if I divide them, I'll write this out fully, but again, you will be able to jump steps a little bit. You get r sine alpha over r cos the alpha, forgot the s, equals 3 over 10. The r's, of course, cancel out because there's r on top and bottom. Sine over cos is tan, so we get tan alpha equals 3 over 10, which means if you use your calculator, alpha equals something. So let's grab our calculator. Okay, I don't know why it lags all the time, but that's fine. 3 over 10, we get, let's call it 16.7. Actually, no, it says to 2 decimal places, so 16.70 then. 16.70 degrees. Now, working out r is a little bit more involved, but essentially you're going to use the fact that sine squared theta plus cos squared theta equals 1. So if we square both of these and add them together, it should equal 1. So we have r squared. Let's do sine first, just to keep it. No, we're going to use alpha. Okay, that was strange. Sine squared alpha plus r cos squared alpha equals 1. And then we can essentially just use the fact that r cos alpha is 10, r sine alpha is 3. But essentially, oops, I forgot to put the squared there. Probably the fastest way to do it, and probably the way that your teachers taught you, the shortcut, is literally just using the fact that you can square and add the two coefficients together. So literally just 10 squared plus 3 squared. So whichever way you want to do it, it's up to you. Actually, no, you wouldn't make it equal to 1. So again, if I write that out, we'll get r squared sine squared alpha plus cos squared alpha And then, of course, we know that sine squared plus cos squared is 10 plus 3 as well. So that goes to 1, and then you get your answer. So 10 squared is 100, 3 squared is 9, so that's square root 109. You can't square root that, so that's it. So our final answer is, it would be r cos, and I think it's theta plus alpha? Yeah, theta plus alpha. So we have, sorry, we don't have r anymore. We have root 109 cos theta plus 16.70. And that's it for part A. So again, I showed you kind of the full way, but if you want to use the shortcuts, I would recommend knowing how to get there, just in case you're a bit unsure of the shortcut on the day of the exam, and you can work it out yourself, because it makes more sense to me personally to do it that way. But let's move on to part B, which is where things start getting a little bit tricky. So for part B, let's read it. The height above the ground, h meters, of a passenger on a Ferris wheel, t minutes after the wheel starts turning, is modelled by this equation, h equals alpha minus, sorry, is that an A? I want to say alpha, minus all of this. Figure 3 shows the graph for 2 complete cycles. It says find a complete equation and then hence find the maximum height. So, finding a complete equation, the first thing that you should notice is that this equation looks almost exactly like this equation, where theta is just equal to AT t. So what I'm going to do to make this a bit easier is I'm going to say h minus, and I'm going to write my equation. There's a reason why I'm doing this, and I'll explain it in 1 second. But again, let's use that little meta-analysis. Why would they get us to do that in part A if we didn't need it in the later parts? Especially when the equations just happen to be the same, right? Now, it says, given that the initial height of the passenger above the ground is 1 meter. Okay, so what does that mean? Well, initial means that, I've just realised, I didn't write the full thing at all. So h equals, I think that might be an A, you know that? H equals A minus. Well, that means that t equals 0, because initial means starting. So when t equals 0, h has to equal 1. Now, why did it make more sense to write it in this form? Well, there's 2 reasons. One, when we work out the maximum, which we can do first, by the way, but if we wanted to work out the maximum, it's way easier to do that when there's only one trig function. When there's 2 trig functions, it's way harder to work out what the maximum is. Whereas instead, if there's 1 trig function, well, the maximum is just 1. Right? It's a lot easier. The second reason is when it says the initial height, imagine subbing in t equals 0 here. Yeah, it's not too bad. Like, that's not too bad to do. But again, it's easier if there's just 1 trig function. But this was mainly for part 2, finding the maximum height. So part 1, you could do it without replacing it. But in my opinion, I think this is a bit easier. So h equals 1, we get A minus, and what I'm going to do is I'm going to sub all of this onto my calculator, just because I'm pretty sure it's going to give me something a little bit ugly, a little bit uggers. So, ooh, careful. Minus root 109, multiplied by cos theta is, I forgot that it's meant to be ATT. Right, because we said up here theta equals ATT. So that would be 80 times 0, so I'm not even going to write it, it's just going to be 16.7. And we get basically 10. 9.99996. Cool. Which means A is equal to 1 plus 9.99996. So we're going to say A is equal to 10, which is indeed the answer in the mark scheme. So we have 10 minus the square root of 109. Let's try not to make any mistakes this time when I write it. Cos ATT plus 16.70. What does part 2 say? Part 2 says, hence find the maximum height of the passenger above the ground. Now, sometimes they ask for the time taken. In this case, they've said the time taken is part C. But in this part of the question, they can sometimes say, find the maximum height and find the time that this happens. But again, they've separated it into 2 questions here, but it's the same principle. So, maximum height. This is where making it one equation is a lot easier, because all you need to do is have a look at this equation and think about what varies. So what part of this actual equation is varying? The 10 always stays the same. The root 109 stays the same. It's the cos function that's varying. And if I look at the whole of a cos function, what does it vary between? It varies between -1 and 1. So the biggest this cos function can be is 1. So if I make that equal to 1, what's my greatest height? Well, again, that's the biggest this can be, right? Is 1. But we're looking at minus over here. So for this to be as big as humanly possible, I want cos to be as small as humanly possible, which means I want the cos function to equal -1, because that'll make it as big as possible. So if they ask for the minimum height, I would say cos is equal to 1, because then 10 minus root 109, well, root 109 was, well, it's probably going to be, what, 10 point something? So that'd be negative, which obviously is not allowed. But in this case, we want the highest possible value, so we're going to make that -1, which means h will equal 10 minus root 109 times -1. So it's going to be 10 plus root 109, which of course is extremely useful. So, again, if they wanted the minimum value, we would then make cos not necessarily as small as possible, but we'd make the overall thing as small as possible by making cos as big as possible. So 10, I'm going to say plus root 109, because I know it's going to be minus and minus. Thanks, calculator. 20 point, does it say how many significant figures? I'm just going to say 20.44. So again, when you're looking at these kind of maximum minimum questions, you have to be really careful. Think about what the maximum minimum of the function is, and then work out which value you want for the overall function. So in this case, the minimum of cos is -1, the maximum of cos is +1. But because I want the whole thing to be a maximum, I need to make cos a minimum because it's being subtracted. And I want to subtract by the smallest number possible. For part 3, there's 2 ways to do this. And I'm actually going to use the way that's very mathematical, because I think that will apply to the most number of people. But again, I'll explain the other way. It says here, find the time taken to the nearest second for the passengers to reach the maximum height on the second cycle. So in other words, if we look at this graph, they want that time. Now, maximum height, don't forget, is when this is a minimum. Okay, it's a minimum value. So we're basically solving equals -1. Okay, so get out your calculators, do this. Now I know some of you use the class diagram. Personally, I would not use the class diagram at all. It's absolutely heinous. But you may know that this will happen at 180. Now I will use the graph. So if we draw the graph, and this is the cos graph here, so we're not using the graph at the beginning because, well, why? Because this is the graph of h, so it's 10 minus this. The cos graph starts at 1 and it goes down, up, and then it will keep doing this forever. And that happens every 360 degrees. So if we label the values, in fact let's do it in black, we have 90, 180, 270, 360, 450, 540. Now, if we think about what it said, this isn't the value we're looking for, because it says on the second cycle. The second cycle means it's already gone round once and it's going to go round again. So we worked out this value when it equals -1, but we want the other value when it equals -1, which is actually 540. Again, normally in questions like this, they're a little bit nicer, and the other value that you work out is just by doing the whole like 180 minus or whatever fun stuff that you get to do. In this case, they've been a little bit nasty by saying it's the second cycle. Again, second cycle means it's gone around once and it's starting to go around again. So in other words, the angle has to be bigger than 360 degrees. So we're going to accept this is our answer, and then all we need to do is work out t, because it says find find the time taken to the nearest second. So 80t plus 16.70 equals 540. So we're going to minus 16.7 from both sides. And then afterwards we're going to divide by 80, but that's 523.3. So then t is equal to, I love having to slide this around the whole time, 6.54 seconds. Actually, do we know it's seconds? It might be minutes. To the nearest. Am I blind? I don't think it tells you. T minutes, there we are. So that's in minutes, and it says give it to the nearest second. So what I'm going to do is, we have 6 minutes. I'm going to take that 0.54, I'm going to times it by 60. That gives me 32.4 seconds. So that is 6 minutes and 32 seconds. That's how long it takes. The second I saw 6.5 seconds, I was like, that is a very fast moving Ferris wheel then. So that means it does a whole loop and a half in 6 seconds, which is pretty funny to think about. So, again, for part C, finding the maximum or the minimum, the two main things I want you to think about is the maximum minimum of the function that actually changes. So again, the 10, the root 109 doesn't change. Then when you're solving it, think about what value you're actually looking for. But part D, again, is the other part where I said some people get a little bit antsy. They get a little bit annoyed about it. Is decided to increase profits. The speed of the wheel is to be increased. How could you model that? So if we look at, if we look at the equation that we actually have here, how would we show an increase in speed? Well, let's think about what an increase in speed actually functionally means, right? If it's moving faster, it means it should take less time to make a full revolution. So in other words, we're looking at this part of the equation because this is the only part that varies, and we want this part to happen faster. So when it's go around faster. The way you would model that is by whatever your time is, you multiply it by a bigger number because that will make it go around faster. Because again, remember, 180 would be half a cycle, 360 would be half a cycle. So if you want this to get to 360 as fast as possible, all you need to do is make whatever's in here bigger, right? Because that will make this faster. Hopefully that makes sense. Because again, cos when it gets to 360 is when it's gone around a full time. So we want it to get to 360 faster, so the best way to do is increase the value of 80. So maybe make it 100, for example. That will make it faster. That was quite a long question, even though it's only 9 marks. Again, the whole modelling with trigonometry section is a little bit tricky. It's not the easiest thing, especially when you have to apply it. But now that I've gone through one, you should be able to use this to help you with a lot of the other questions. So if you found any of that useful, please do consider subscribing and liking all that fun stuff, because it really does help me out. But I'll leave you to your work, and I'll see you in the next one.